Welcome to homework.
Okay, so one way we can go about answering this question is to, well, first let me redraw the Fischer projector, or the bond line diagram. Okay, so we've got a wedge here to OH. Okay, we've got a dash here to OH, a dash here to OH, and a dash here to OH. Great. Now, one way we can go about this is we can just figure out what the absolute configuration of each of these stereocenters is, and then pick a Fischer projection or develop a Fischer projection that will match this same configuration, right? So if we have a wedge to OH, right, OH is going to be our highest priority. Second highest priority is the carbon with an OH, and methyl would be third. Hydrogen is them in the back in this case, right? So this would be counterclockwise, which would make this first one S. Okay, so we know we've got an S here. So that's how we can go about this. Okay, next we say, okay, OH is highest priority. Then the carbon that's got two OHs over here is going to be higher priority than this one. So this is 3. And this is clockwise. But in this case, since we have hydrogen in the front, right, clockwise isn't R, it's S. We have to reverse it, right? Because, for example, if we put if we swapped hydrogen and OH, it would look like it's R, but we would swap, and so we'd know it's the opposite enantiomer from that, right? So the second one is also S. And then we can do the same thing here. Highest priority, second highest priority, third highest priority. It looks like it's going to be clockwise, right? But hydrogen is in the front, not in the back, right? So it's actually the opposite. It's counterclockwise, which means this one is also S. And then finally, once again, highest priority, second highest priority, third, looks counterclockwise, except for hydrogen's in the front, not in the back, right? So you have to reverse it, and that means that this is clockwise. So the final one is actually R. So we have SSSR. Okay, now how do we interpret this? So let's make our Fischer projection, right? So this is the CH3 at the end. Okay, and this carbon will be this carbon, right? So if we wanted to make this S, well, let's put the rest of these in here. Okay, right? Remember that what a Fischer projection is like this sort of shape right here, right? So if we want to determine chirality, basically all we have to do is assign priorities to these groups. And then if we have the lowest priority here, priority 4, then we can simply read it clockwise or counterclockwise. If we don't have the lowest priority there, if it's, for example, here on the bottom, right, then we can still just read counterclockwise. But if the lowest priority is on one of these, then we run into that situation where clockwise is S and counterclockwise is R. Okay. So is the lowest priority going to be in the front or the back? Yes, because this methyl is going to be the lowest priority, right? So then we determine, one of these is going to be a hydrogen, right? One of these has to be a hydrogen. So our lowest priority for none of these will be in the back, right? So every time clockwise will be R and clockwise will be S and counterclockwise will be R, right? Because in every one of these examples, we're going to have our lowest priority not in the back. Okay. So given that, let's say the oxygen was on the right. That would put the highest priority here, the second priority here, and the third priority there, right? So is that going to be clockwise or counterclockwise in that case. It's going to be counterclockwise, right? But that's actually going to be R. Okay, we want it to be S, so we know that ROH goes on the left. And then we just keep repeating this process. Then assume, again, that OH is on the right. So this becomes the highest priority. And the second highest priority becomes this one. And the third highest priority is that one, right? And that's R again. We want it to be S, so we know that OH must go over here. Okay, same thing here. Let's assume OH is on the right. And this is the highest priority. This is the second highest priority. Third is here, right? And now that's looks like that's going to be S, but that would be we have to swap it because the hydrogen's not in the back. So this will be R as well. But we want it to be S, so OH has to go on the left. And the final one, assume it's on the right. Highest priority, second highest priority, third highest priority, clockwise would correspond to S. And that's actually what we want because we actually want R if hydrogen's not in the back. So we do know that the OH is on the right in this case. So this is what we're looking for. Do any of the Fischer projections match this? 3 on one side and 1 on the other. Number 3 does. Right? And it's okay that they have 3 on the right and 1 on the left because we could just rotate the whole thing around, right? And we get the shape exactly like ours. So all that matters is that there's 3 on the left and 1 on the right.